So we've now seen these first two layers of structure. Firstly, the part of speech tags for the sentence, and secondly, the sequence of chunking decisions. We're now going to see the third layer of structure where the remaining parts of the parse tree are built. And again, the game here is to encode those remaining parts of the parse tree as a sequence of decisions. So the decisions we'll see are join or start or check. And so we're going to alternate between two classes of actions. First, we'll choose either join x or start x, where x is some label, for example np, s, vp, and so on. And after each point where we've chosen join or start, we then choose check equals yes or check equals no. I'm going to illustrate this with our example tree over the next few slides, so this will at first appear rather abstract, but hopefully as I go through the example things will become more clear. At a high level, here's the meaning of these actions. So start x is going to be an action that starts a new constituent with label x. For example, we could start a new np, or we could start a new s, we could start a new vp, and so on. And it always acts on the leftmost constituent, which has no start or join label above it. Join x is similar, except it continues a constituent with label x, and again it always acts on the leftmost constituent with no start or join label above it. So intuitively, the first thing we'll do is choose whether to either start a new constituent or to continue an existing constituent. And then we'll apply this check operation. So check equals no means we do nothing, essentially. But if we say check equals yes, then as we'll see, this will take the previous join or start action and convert that into a completed constituent. Okay, so that's the abstract description. Now let's see how this pans out for this particular example. So here's the state we've reached after the first two levels of decisions, namely the part of speech tagging decisions, this layer here, and secondly the chunking decisions, which were to choose this chunk, and this chunk. So this is the structure we've built in the first two n decisions, where n is the length of the sentence. The next thing I'm going to do is pick the leftmost constituent, which has no join or start annotation above it. That's this NP in this case. And I'm going to choose either to start or join a constituent here. In fact, start is really the only option because I can't continue a constituent. No constituents have been built at this point. And in fact, for the parse tree that we saw for this sentence, this decision will be to start an S. Because if you remember, we actually have something like this in the structure of the tree. So this is the and lawyer. The non-terminal above this NP was an S, and this is basically making the choice to start that S. The next thing we do is a check operation. And so there were two possibilities, check equals yes and check equals no. So if I'd chosen check equals yes, that means I would have actually have said, okay, this S constituent is complete, this one I've just started. And then I would have built this S and said, okay, that's a complete constituent. For the parse tree I showed you for this sentence, this S has more than one child, and so we definitely don't want to say check equals yes and complete the constituent at this point. So check equals no, and basically that means we leave this structure unchanged. The next operation is to look again, we look at the leftmost non-terminal that doesn't have any structure above it, or rather it doesn't have start or join above it. That rules out this structure here, so we look at this first part of speech here. And we could either choose to start a new constituent, or we could choose to join S, which would mean we'd continue this S constituent. In this case we choose start VP, because if you think about the structure in the tree, the correct parse tree in this case has a VP started at this point, and that's what this decision here reflects. The next thing is again a check operation. We say check equals no. If it was yes, we would have completed this VP, and we would have this structure here. But that is actually incorrect for this sentence, for this parse tree I've shown you. And so check equals no, we leave this VP uncompleted. Next step, again, we go through this process of finding the leftmost non-terminal, which doesn't have any structure above it. That's this NP in this case, because this has structure, this has structure. And we could choose to start a new constituent, or we could choose to join an existing constituent. In this particular case, we're going to choose join VP, which means that this noun phrase is actually going to be the second constituent under this particular VP. We go through a check operation. We could say check equals no or check equals yes. And for this particular parse tree, I actually had three children. I had a VT, I had an NP, and I had a prepositional phrase coming up, which is going to be built over here. So in this case, we're going to say check equals no. Otherwise, I would have immediately completed this constituent VP with these two children underneath it, and that would not be correct for this particular parse tree. Next step, you're hopefully getting the idea now. We pick the leftmost subtree that doesn't have any structure above it. That's this preposition here. We could choose to join the previous constituent or start a new one. We say start PP in this case. The prepositional phrase isn't complete, so we say check equals no. Again, we go back to the leftmost constituent that isn't completed or doesn't have structure above it. That's that NP. We could start a new constituent, or we could choose to join the previous one. In this case, we choose to join the prepositional phrase. And now finally, something interesting happens with respect to the check operation. So let me go back to the previous state. So this is the position I've reached, and now I'm going to do a check, which is basically going to say, is this constituent, this prepositional phrase, this most recent constituent that I built, is this now complete? Now in this case it is complete. There's nothing more to the right. So there's no way we can build any additional structure. And so in this case we say check equals yes. And notice that we've now built this prepositional phrase. Okay? So we've now converted that start join structure to this prepositional phrase structure. And then we continue. We're going to pick the leftmost structure which has no join or start label above it. That's this prepositional phrase. We can choose to start a new constituent or join a previous one. We choose to join VP in this case. That means we're going to extend this verb phrase that we've been building. And again, we're going to follow this with a check. And in fact, if we think about this, the only thing we can really do here, because there are no more structures to our right, is say check equals yes and complete this verb phrase. And that indeed is what happens. So check equals yes, and notice I now have VP with these three children underneath it. I pick the leftmost structure. I choose in this case join S as my decision. I now have these two structures in sequence. I'm going to do a check operation. The check in this case equals yes. And at that point I've actually completed the tree. So that's a sketch of the sequence of decisions for this particular parse tree. So let's just go back to what we're trying to achieve here. Remember, the game is to try to come up with a sequence of M decisions which describes how the parse tree is constructed. The first N decisions are level 1. Those are the part of speech tagging decisions for each individual word. The second N decisions are level 2. They correspond to the chunking decisions in the particular parse tree. And the remaining decisions are level 3, are these start and check operations that build the remaining structure. And notice again that we alternate. We always have start check or join check until the final structure, the complete parse tree, is built. But anyway, to summarize, This is the way that Ratnapaki chose to represent paths trees as sequences of decisions. Firstly in part-of-speech tags, secondly in chunks, and finally in these start, join, and check operations that build the higher levels of structure.